The difference between a duplicate report and a high-impact bug usually comes down to one thing: reconnaissance. If you are only looking at the main target and the obvious subdomains, you are missing 90% of the attack surface. Welcome to CavemenTech. Today, we are putting it all together. This is the ultimate Bug Bounty Recon Masterclass. We have merged over 10 of our top web reconnaissance lectures into one massive, complete course. We are going to cover it all. We will start by mapping hidden website details using OSINT. Then, we will dive into ASN enumeration to find unmonitored IP ranges, bypass Cloudflare to unmask origin servers, discover hidden directories, analyze security headers for quick wins, and finally, chain automated vulnerability scanners together to do the heavy lifting for you. Every technique we cover relies on passive intelligence, public records, and authorized targets. Always check your program's scope, grab a coffee, and let's map the web. In the world of open source intelligence, or OSINT, the internet is our vast ocean of data, and one of the largest, most fundamental sources of information we encounter every day are websites. They are the digital storefronts, the personal blogs, the corporate hubs, and the hidden corners where individuals and organizations leave a wealth of clues. Today, we begin a new module where we'll explore Website OSINT, how to effectively extract crucial intelligence from these digital foundations. And as you'll soon learn, when it comes to leaving a digital footprint online, you can't hide. And over the next set of lectures, we will systematically break down how to extract valuable intelligence from any website. Websites are unequivocally your first point of contact in almost any OSINT investigation. Whether you're targeting a large corporation, a small business, or an individual, their web presence, or lack thereof, is highly significant. Organizations use them as official storefronts and information hubs, and individuals often maintain personal blogs, portfolios, or various online ventures that serve as rich data sources. This makes the web an incredibly vast and accessible source of public information ready to be analyzed. In this module, we have several key goals. By the end, you'll be able to, first, identify the owner or network administrator of a website. Second, map out hidden directories and pages. Third, discover associated subdomains and server IP addresses. Fourth, determine the technology stack used to build the site, which can reveal vulnerabilities. Fifth, find email addresses of employees or key contacts. And finally, critically, uncover any confidential information that might have been accidentally exposed on the website. We're going to start with a fundamental technique: whois lookups. So what exactly is a whois record? In simple terms, it's a public database entry that reveals who owns a particular domain name. When someone registers a website, they are required to provide certain information, which then populates this record. Typically, each whois record contains the domain owner's name and their contact details, crucial for direct identification. The registration and expiration dates of the domain giving us a timeline, and information about the domain registrar, the company through which the domain was purchased. It's important to understand that whois databases are maintained by specific organizations called Regional Internet Registries, or RIRs. These RIRs manage IP addresses and domain name registrations globally, and they are the authoritative source for this data. A typical whois query can return a wealth of key data points, including we get contact details of the owners, which could be their name, address, phone number, and email. We see the domain name servers and net range, giving us clues about the hosting infrastructure, and vital creation, expiry, and last updated records, providing a timeline of the domain's activity. For an OSINT investigator, this information is invaluable. It helps us gather direct personal information, create a map of a target organization's network, and even obtain internal details about their infrastructure or previous configurations. Let's jump into our first demo with a straightforward and widely used tool, who.is. This is often my first stop for a quick whois lookup. I'm here on who.is. I'm going to search for megacorp1.com to get a quick overview of its registration details. As you can see, it immediately provides us with the details about the registrar, critical dates like creation and expiration, and the name servers. This gives us a solid baseline of information to start with. It's clean, simple, and fast. You can also click on Raw Data tab to see if any other information is available about the domain. In this case, we do not have anything else. For a more feature-rich, web-based whois experience, I often turn to whois.com. While it provides the same core data, its interface can sometimes present it more clearly or offer additional navigation options. Let's search for megacorp1.com again, but this time on whois.com. Here, you can see similar details, but often presented with clear headings like domain information, registered on, expires on. It reiterates the domain status and lists the name servers. The layout can sometimes make it easier to quickly scan for key details, especially if you're dealing with a large volume of lookups. Importantly, it also provides registrant information, including the company name, physical location, and multiple email addresses. These details can be valuable for further investigation and help us build a clearer picture of the entity behind the website. When you need a more advanced or comprehensive whois lookup, especially for professional investigations, DomainTools.com is a go-to resource. While some of its deeper features are behind a paywall, their free whois lookup still provides excellent data and cross-referencing capabilities. Let's try megacorp1.com on Domain Tools. Notice the level of detail here. Beyond the standard information, Domain Tools provides insights like the domain's age in days, its creation and expiration dates, and a more detailed breakdown of its name servers and their associated domains. It also clearly identifies the IP address and its geographical location, linking the digital asset to a physical presence. We also have complete information about the registrant, like name, state, address, and the email address. Domain Tools is particularly useful when you need to pivot into other related OSINT tasks, like reverse IP lookups. For those of you who prefer command line tools or are working within a Linux environment like Kali Linux, a native whois command is often available. This can be faster for quick lookups and integrates well into scripting. Here, I have a Kali Linux terminal open. I can simply type whoiscertifiedhacker.com. As you can see, the output is raw text, but it contains all the same core information we saw on the web-based tools: domain name, registrar, contact emails, registration dates, and name servers. Understanding how to use command line tools is a valuable skill in OSINT for automation and efficiency. Finally, for Windows users, or if you prefer a dedicated desktop application, tools like SmartWhoIs offer a graphical interface for performing whois lookups. These can be useful for managing multiple queries or integrating with other local tools. You can download the application directly from Tamosoft's official website. Once downloaded, extract the files and proceed with the installation. Here's SmartWhoIs on my Windows machine. I'll enter certifiedhacker.com. The tool retrieves and displays the whois information in a structured format, similar to the web interfaces. It gives us the owner's contact details, registration dates, and DNS information, all within a familiar desktop application environment. The choice of tool often comes down to personal preference and workflow. So far, we've explored the current WHOIS record, but what happens if the domain owner updates their information or even sells the domain? Moreover, we've seen most modern WHOIS entries are now redacted, making it increasingly difficult to access registrant details. This is where historical WHOIS becomes invaluable. It allows us to access older records, uncover previous ownership details, and track how a domain has changed hands over time. Our first tool for historical WHOIS is whoisfreaks.com. This site provides a historical database of WHOIS records, allowing you to see past owners and contact information that might no longer be in the current record. I'm on whoisfreaks, and I'll search for packwheels.com. As you can see, it retrieves historical records for the domain. Multiple WHOIS entries are displayed, sorted by date and year. These include creation and expiry dates, as well as past registrant details, such as names, company names, countries, old email addresses, and phone numbers. While most recent WHOIS records are redacted, if we scroll down to earlier entries, we can often find unredacted registrant information. In this case, we see the registrant is Pocky Ventures, along with their email address and phone number. Similarly, if we search the historical records for Udemy, many entries are redacted. However, one record reveals the original registrant, Aaron Bali, the founding CEO. His email and phone number are also visible. This kind of historical data is incredibly valuable when a target has attempted to obscure their current information or when you're tracking the evolution of a domain over time. Or truly in-depth historical WHOIS analysis, Domain Tools' research platform is unparalleled. While it's often a paid service for full access, it provides deep insights into the evolution of domain ownership. On Domain Tools' WHOIS history for packwheels.com, notice the summary. We have 947 historical records for packwheels.com and 179 significant changes. It also highlights that about 84% of the records publish domain name ownership data, meaning a significant portion isn't hidden by privacy services. This gives you a clear indication of how much historical data is available and how active the domain's ownership has been, guiding your further investigation. Although in free tier, we cannot get the complete data, but we can get an overview of the WHOIS history of a domain. For those who need to perform historical WHOIS lookups at scale or integrate them into automated workflows, API-driven services like whoisxmlapi.com are indispensable. On their WHOIS history page, you can see how their API can retrieve vast amounts of historical data. While the demo limits us to just a few records, their archive boasts over 23 billion WHOIS records. This is the kind of service that allows you to automate the collection of historical ownership data for large-scale investigations, processing thousands of domains at once. Another excellent tool for historical WHOIS data is Woxy.com. Woxy is known for its extensive archives and often presents the data in a clear chronological order, making it easy to track changes. Let's search for packwheels.com on Woxy. Here we get a timeline of WHOIS records. You can see how the name, company, email, and status of the domain have changed across different dates, like 4 January 2017 and 12 October 2017. This provides a dynamic view of the domain's ownership history, which can be crucial for uncovering long-term patterns or identifying previous owners. Now, let's flip the script. Instead of finding out who owns a domain, what if you have an owner's name or email, and you want to find all the domains they own. This is where reverse whois comes in. It's a powerful technique for finding websites owned or managed by the same entity, greatly expanding your target's digital footprint. Let's start our reverse whois demos with whoisfreaks.com again. This site allows you to search their whois database using an email address, which is a common pivot point in OSINT. I'm here on their reverse whois search page. I'll enter a known email address associated with the packwheels.com domain we looked at earlier, admin@packeventures.com. Immediately, we get a list of domains associated with that email address. We see packwheel.com, tringtring.com, and luckystarmotors.com. This is incredibly useful for mapping out an individual's or organization's broader web presence, finding sister sites, or discovering new ventures linked to your target. Another reliable tool for reverse whois is viewdns.info. This site offers a wide range of DNS-related tools, including a robust reverse whois search. Let's use the same email on viewdns.info. Here, we get a clean list of all domains registered with that email address. It confirms some of our previous findings and potentially reveals even more domains. Tools like viewdns.info are crucial for building a comprehensive network map of your target's digital assets. ReverseWhois.io is yet another specialized platform that focuses purely on reverse whois lookups. It's often updated with fresh data and can catch domains that other tools might miss. Again, let's search for admin@packeventures.com on reversewhois.io. The results are displayed clearly, showing the domain name, creation date, and registrar. The more tools you use for reverse whois, the more complete your picture will become. Each service pulls from slightly different datasets and update cadences, so combining them maximizes your coverage. Our final section in this lecture focuses on expanding your reconnaissance beyond known domains, finding similar sites. This technique helps you uncover websites that might be related to your target based on keywords, topics, or even similar domain structures, even if they're not directly linked through whois records. Our first tool for finding similar sites is instantdomainsearch.com. While primarily a domain registration tool, its search capabilities are excellent for quickly identifying available or registered domains containing specific keywords. Let's search for the keyword packwheels. You can see it instantly generates a huge list of domains that contain packwheels, along with various top-level domains like .club, .link, .blog, and even premium domains. This is fantastic for identifying potential brand abuses, related ventures, or simply mapping out the ecosystem around a particular keyword or brand name. This can be important because whois records for the main domain might be hidden, but related domains owned by the same organization are sometimes left exposed. These supporting domains often aren't protected the same way. We can simply click the whois option to view the record for each domain. By checking them one by one, we might uncover additional information that isn't available in the primary domain's record. DNS Checker offers a domain name checker tool that helps you see the availability of a domain across different top-level domains and provides some whois info. This is useful for understanding a brand's full domain footprint. Let's search for udemy.net here. It shows the availability of Udemy across various TLDs like .com, .net, .org, and .io. It quickly tells you which ones are taken and which are available. This is crucial for understanding how a brand protects its digital identity and what other domains it might own, even if they're not actively used. One excellent feature of this site is that you can click on any domain and its Whois record will be displayed in the main panel. This makes it much easier to trace an organization or individual associated with the domain. For a more in-depth look at domain information and finding neighbors based on shared attributes, DNSlytics.com is a powerful resource. It goes beyond simple keyword matching to find more technically related domains. Let's search for pack wheels here. It shows various domains containing pack wheels and even gives insights into their domain rank, IP addresses, and DNS servers. This can reveal clusters of sites hosted on the same infrastructure or belonging to the same network, even if direct ownership isn't immediately apparent through Whois. So, to summarize our journey through website OSINT, remember this workflow. First, start with a standard Whois lookup to identify current ownership, key dates, and registrar information. Next, dig into history using historical Whois tools to uncover past owners and track changes over time. Then, expand horizontally by using reverse Whois. This allows you to find other domains owned by the same individual or organization, often through an email address. And finally, broaden your scope by searching for similar sites using keywords to discover related domains or potential brand affiliations. As always in OSINT, verify everything by cross-referencing information found across multiple tools and sources. This comprehensive approach to website OSINT will equip you with powerful techniques to uncover deep intelligence from any online presence. Thank you for joining me in this lecture, and I look forward to seeing you in the next one. Hello, and welcome back. In this lecture, we're moving deeper into website OSINT to answer a critical question. What is this website built with? We're going to learn how to find a site's technology stack. This is a fundamental skill for any investigator, as the technology a site uses can tell you a lot about its capabilities, its purpose, and most importantly, its potential weaknesses. So, why does the tech stack matter from an OSINT perspective? Because identifying a website's underlying technology helps us understand its infrastructure and its security posture. For an investigator or ethical hacker, finding out a website is running on an outdated version of WordPress isn't just a fun fact, it's a critical piece of intelligence. It means there could be known exploitable vulnerabilities. From these tools, we can find key information like the CMS or content management system like WordPress or Drupal, the LMS or learning management system if it's an educational site, specific plugins and their versions, and much more like the web server type, frameworks, and analytics tools. Our first and fastest method for identifying a tech stack is by using a browser extension. The go-to tool for this is Wappalyzer. It's an extension you install in your browser that analyzes a site in real time as you visit it. You can install the Wappalyzer extension on either Chrome or Firefox. For this demo, I'll be using Firefox on Kali Linux. Let's start by searching for Wappalyzer Firefox extension on Google. Click on the official Firefox add-ons link. Now click Add to Firefox. The extension will automatically download and install into your browser. To make the extension easily accessible, pin it to your toolbar. Just click on the extensions icon in the menu bar and select Pin to Toolbar next to Wappalyzer. Now, you're ready to view the technology stack of any website. Just visit a site and click the Wappalyzer icon. Let's test it on Facebook.com. As you can see, Wappalyzer detects that Facebook is using HSTS for security and Open Graph for social metadata. However, there's limited information here because Facebook's developers actively hide their technology stack for security and privacy reasons. Now let's try pocwheels.com. Here, we get a much more detailed breakdown. The site is using Facebook integration, Google Analytics, and Cloudflare CDN. We can also see that it uses Firebase as its database and is built with Ruby on Rails. Even version details are visible, which is especially useful for penetration testers or ethical hackers looking to understand potential vulnerabilities. So, Wapalizer is a powerful and convenient tool to quickly gather valuable information about a website's technology stack. When you need a more comprehensive report than what a browser extension provides, you turn to online scanners. Our primary tool for this is builtwith.com. It's one of the most detailed technology profilers on the web. I'm on BuiltWith, and let's run a scan for certifiedhacker.com. Look at the level of detail here. It breaks down technologies into categories like analytics and tracking, widgets and frameworks. It even provides us with email and web hosting provider information. Moreover, it provides historical data, telling you when a technology was first or last detected, which can be invaluable for tracking a site's evolution. A great, clean alternative to BuiltWith is the stack detector on OSINT.sh. It provides a similar report but presents the information in a very simple, easy-to-read card format. Let's run the scan for the same site through OSINT.sh. You can see it has clearly identified the client-side language, the web server, the hosting provider, and the SSL certificate authority. Using both BuiltWith and a tool like this gives you a very complete picture. If your primary goal is to quickly identify the content management system, a specialized tool like whatcms.org is perfect. It focuses specifically on detecting the CMS and its version. Let's run a search for securetackles.com. And there it is. In seconds, it confirms the site is using WordPress version 6, 8.2, and also uses the Elementor page builder version 3, 20.4. Getting these exact version numbers is critical for vulnerability research. We even have social media links of the company. We have Facebook, Instagram, and LinkedIn links for our target, which is crucial for our information gathering. Our final method is for power users, scripters, and those working in a command line environment like Kali Linux. The essential tool for this job is WhatWeb. It's a next-generation scanner that provides incredibly detailed information, including HTTP headers and version numbers, right in your terminal. Here is the output from running WhatWeb on a target domain. Look at the results. It not only identifies technologies, but often gives us version numbers, as well as important headers. Because it's a command line tool, you can script WhatWeb to scan hundreds or thousands of websites automatically, making it indispensable for large-scale reconnaissance. So, to summarize, we've learned 3 distinct methods for finding a website's technology stack. Which one should you use? It depends on your goal. For a quick real-time check while you're browsing, use a browser extension like Wapalizer. It's fast and effortless. For a detailed, comprehensive report with historical context, use an online scanner like BuiltWith. And for automation, scripting, or deep technical analysis within a pen testing workflow, use a command line tool like WhatWeb. Mastering these 3 methods will allow you to quickly and accurately profile the technology of any website you encounter. Thank you for joining me in this lecture. In our next video, we'll build on these concepts and explore even more ways to extract intelligence from websites. I'll see you there. Hello and welcome back. In this video, we're going to roll up our sleeves and dive into manual web reconnaissance. This is the art of using nothing but your browser and your brain to explore a website, understand its features, and find clues that automated scanners often miss. Our goal in manual reconnaissance is to think like an attacker. We are actively looking for a website's interactive features, the places where a user can input data, because these are the most common attack surfaces. Our objectives are to manually explore the site and find key attack surfaces like login pages, contact forms, and search bars. Hidden content, like unlinked pages, developer comments left in the code, or forgotten subdomains. And infrastructure clues that tell us about the underlying technology stack and server configurations. We're now on our demo website, Hack Smarter Manufacturing Shop. Our first goal is to identify all publicly accessible pages, directories, and possibly user information on this site. Start by casually browsing the website like a normal user would, and try to spot anything useful. While exploring, we stumble upon the CEO's name, Tyler Ramsby. That's our first piece of OSINT, valuable personal data that could help in further investigation. Scrolling to the bottom of the page, we find two important links, a team page and a history page. Let's open the team page first. This is a gold mine. We now have employee names, job titles, and even email addresses. This kind of contact information is extremely useful. We can use it to craft phishing campaigns or conduct further OSINT to find more about these individuals. We even have photos of the employees. You can try reverse image searching these to discover public social media profiles or other platforms they may be active on. Now let's check the history page. It contains a complete background of the company. Another valuable source that might help us understand the organization better or identify key dates, projects, or decision makers. Now let's move on to technical OSINT. From our tech stack analysis, we can tell that this website is built using WordPress. So our next step is to locate the login page, where we can attempt username or password testing during a legitimate engagement. A quick Google search tells us that WordPress login pages are commonly found at /admin/login or /wplogin.php. Let's try those. And yes, we found the WordPress login page. Next, let's try to enumerate users on the site without any advanced tools. We'll use our Google View and OSINT blogs to guide us. One helpful method shared by HackerTarget involves using the author parameter in the URL. Let's try author equals ~1 on the site. And there it is, we've successfully discovered a valid username. You can repeat this with different numbers like author equals ~2, author equals ~3, and so on to enumerate more users. So, using only basic OSINT techniques, browser tools, and search engine tricks, we've already gathered a significant amount of information about the target without touching any automated scanner or intrusive tool. This is the power of OSINT. Now, we will dig deeper in manual web reconnaissance process to gather more information about our target. Let's start with the most basic but essential technique, looking at the page source. Our first phase is analyzing the page source. This is the raw HTML, CSS, and JavaScript code that the web server sends to your browser. While it's meant for the browser to read, it often contains hidden gems for an investigator. We're looking for things like developer comments, sometimes containing notes, debugging information, or even credentials. We look for hidden links to staging environments or secret pages. To view the page source on any website, you can simply press Ctrl+U or right-click and select View Page Source. And we look for clues in the script paths. In this example, the comment "proudly powered by WordPress" and a link to wordpress.org instantly tells us the CMS of this website. I'm currently on a university website. Let's open the source code by pressing Ctrl+U. Here, we can see the full HTML structure of the page, including the URLs that different sections are pointing to. These links can sometimes reveal hidden directories, subdomains, or internal pages not visible through normal browsing. As we scroll through the source code, we also come across various JavaScript and CSS files being loaded. These can give us hints about third-party libraries or frameworks being used on the site. Now, if we scroll further down, we can clearly see a comment or line mentioning that the site is powered by WordPress. At the very bottom, we also notice a reference to Redis Object Cache, a strong indication that the site is using Redis for performance optimization or caching. These small but valuable details are part of what we call technical OSINT, revealing insights about a site's backend just by analyzing publicly available data. Next, we move to the browser's developer tools, which you can open by pressing F12. Our first stop is the Inspector or Elements tab. Unlike the page source, this shows you the live state of the website, including any changes made by JavaScript after the page loads. In this example, the web page appears completely normal at first glance. But when we open the inspector, pressing F12, we can view the live HTML structure of the page. Here, we notice a hidden element with the ID flag. This element doesn't show up visually on the page, but it's clearly present in the code. This is a classic capture the flag technique, hiding information within the page's structure. In real-world scenarios, similar methods might be used to hide debug parameters, API endpoints, or even sensitive data unintentionally exposed in the front end. To reveal it, we can modify the CSS directly in the browser. Simply change the display property from none to block. And now, the hidden text becomes visible on the page. This demonstrates how valuable the browser's developer tools are. Staying within the developer tools, let's now move to the Debugger or Sources tab. This section allows us to analyze the website's JavaScript files and other static assets directly, and it's often a goldmine of information since this is where much of the application's core logic resides. On our target website, open Developer Tools and click the Sources tab. Here, you can see a full list of files the page has loaded. It reveals the site's directory and folder structure, and in this case, we can clearly identify the classic WordPress layout. We can click on any file to view its contents directly. We can identify the WordPress theme being used, And in the Uploads folder, we even find the CEO's image. This kind of passive file browsing can reveal a lot, including user-uploaded files, configuration errors, or sensitive media unintentionally exposed. Another very useful tab is the Network tab. This gives us a live view of all HTTP requests and responses as they happen in real time. Let's click on the team page link. Immediately, we can see the new requests that were made, including the HTML content, images, JavaScript files, and other assets that were fetched. We can even open any of the JavaScript files and manually inspect the code. By reading the code carefully, we can sometimes deobfuscate it to understand its true behavior, discover hidden API endpoints, or see how user input is validated or not validated on the client side. This is a more advanced manual OSINT and Recon technique, but it's incredibly powerful for anyone doing serious analysis or penetration testing. Now we move to our third phase, looking at server configuration files. The first one we always check is robots.txt. This file is designed to tell search engines like Google which pages they should not index. For us, it's a treasure map of places the website owner doesn't want people to find easily. To view it, you simply go to the domain and add /robots.txt to the end of the URL. Here, you can see entries like disallow admin or disallow login. These are directories the site is explicitly trying to hide from search results, making them our first targets for manual exploration. The counterpart to robots.txt is sitemap.xml. This file gives search engines a complete list of every page the owner wants them to find. This is useful for us because it provides a comprehensive map of the entire website structure, often revealing pages that are difficult to navigate to manually, or even old pages that are no longer linked but still active on the server. Just like we do with robots.txt, we can also check for a site's sitemap by simply adding sitemap.xml to the domain. If it exists and is publicly accessible, the sitemap can reveal a structured index of the website's pages. In many cases, the sitemap includes links to category-wise subsitemaps. For example, blog posts, products, tags, or author pages. Let's explore it further by copying one of the sitemap links and opening it in a new tab. Here, we now have a list of all blog post URLs from our target website. And yes, we can open any of them directly. This technique gives us a quick and reliable way to discover hidden or lesser-known pages without needing any scanning tools. So in this way, by simply accessing the sitemap, we can easily enumerate pages, directories, and content that the site itself has indexed for search engines. Finally, let's take a look at HTTP headers. Every time you make a request to a web server, it sends back hidden response headers along with the actual web page content. These headers carry valuable metadata about the server, such as technologies in use, caching behavior, security policies, and more. You can view these headers in the Network tab of your browser's developer tools by clicking on any request and navigating to the headers section. Alternatively, you can use a command line tool like curl. In our case, we can see several interesting headers that reveal technical details about the site, such as the server type, content encoding, or even security headers like strict transport security or X-frame options. These headers are particularly important during the web penetration testing phase, as they can indicate potential misconfigurations, missing protections, or opportunities for exploitation. Let's summarize our manual reconnaissance workflow into a clear, three-phase process. First, the surface phase. Manually browse the site and view the page source to find initial clues like developer comments and hidden links. Second, go under the hood. Use your browser's developer tools to inspect live elements and dig into the JavaScript code. And third, check the server instructions. Look for the robots.txt and sitemap.xml files, and analyze the HTTP headers to learn about the server's configuration. By following this manual process, you will build a deep understanding of your target website and find vulnerabilities that automated tools will always miss. Thank you for watching, and I'll see you in the next lecture. Hello and welcome. In this lecture, we're going to travel back in time. Websites are not static. They change constantly. Content gets deleted, designs are updated, and entire companies rebrand. But what if the clue you need is on a page that no longer exists? That's where we dive into the world of web archives to find historical links and data. This is a fundamental OSINT skill that allows you to see the internet as it once was. Our journey begins at Tier 1 with the most well-known tool in this space, the Wayback Machine at archive.org. It's a massive historical archive with over 800 billion web pages saved over time. For an OSINT investigator, its applications are immense. We can view deleted content and see what a website looked like years ago. We can find old information, like contact details or About Us pages that have since been removed. And critically, we can discover old pages or subdomains that might still be active on the server today, even if they aren't linked anywhere on the current site. We're now on the Internet Archive homepage, commonly known as the Wayback Machine. Let's use Facebook as an example to see how its homepage has changed over time. Type in the Facebook URL, facebook.com, into the search bar and hit enter. The Wayback Machine will now show us a timeline of all the snapshots it has archived for that domain. Keep in mind, the Internet Archive tends to capture more snapshots of popular websites, especially in later years. You can select any year from the timeline and then choose a specific date to see when snapshots were taken. Let's click on one of those snapshots. Here, we can see what the Facebook homepage looked like in 2008, a much simpler and different design compared to today. If we go back even further, say to 2005, we can see that the page looked completely different. The Wayback Machine is a powerful OSINT tool that lets you track changes to a website over time and even recover deleted or modified content that's no longer available on the live site. But what if the Wayback Machine doesn't have a copy of the page you need? That's when we move to Tier 2, the Meta Archive. Our tool here is the Memento project. Memento is not an archive itself, it's an aggregator. It searches across dozens of different web archives from all over the world simultaneously. Archives from places like the U.S. Library of Congress or National Archives in other countries. This allows you to cast a much wider net and find snapshots that might not exist in more common archives. Using Memento is simple and incredibly useful, especially when your primary sources like the Wayback Machine don't have what you're looking for. Just go to timetravel.mementoweb.org, enter the URL of the page you're investigating, and select a date you're interested in. Memento will then search across multiple web archives, not just the Wayback Machine, and find the version of that page that's closest to the date you selected. In this example, we received a result from the Portuguese Web Archive. This shows just how valuable Memento is when other archives come up empty. It casts a wider net and often uncovers regional or less common snapshots. So if you're doing deep OSINT or digital investigations, Memento is an essential tool for retrieving historical web content across multiple sources. Finally, we arrive at Tier 3, the most powerful and technical level of web archiving, Common Crawl. This is not a user-friendly, browsable archive like the Wayback Machine. It is a massive open repository of the raw data from crawling the internet. For an advanced OSINT investigator, this is the deepest dive you can take. You can find pages or technical data that other archives might have missed. You can programmatically search across billions of pages for specific keywords, email patterns, or even Google Analytics IDs to link different websites together. To use it, you can go to the Common Crawl Index. You select a recent crawl, and you can then query it for a specific URL pattern. The result, as you can see, isn't a web page. It's a JSON object containing the raw metadata about the crawl, the exact URL, the timestamp, the server status, and the location of the raw content within the massive archive file. This is for highly technical, large-scale analysis, and if you want, you can just query the database and download the site's data. Let's summarize our three-tiered approach to finding historical web data. For Tier 1, your quick and visual search, use the Wayback Machine. It's perfect for browsing old site versions and finding obviously deleted content. For Tier 2, a broader search, use Memento. When you need to cast a wider net across many global archives, this is your tool. And for Tier 3, the deep and technical dive, use Common Crawl. This is for analyzing raw data at scale and performing advanced programmatic investigations. By understanding these three tiers, you can choose the right tool for any historical investigation. Thank you for watching, and I'll see you in the next lecture. Hello and welcome back. So far in our module, we've learned how to find information about a website's past and its present state. But what about its future? In this lecture, we're diving into the proactive world of website monitoring. We'll learn how to automatically track websites for uptime, changes, new backlinks, and even signs of malware. This is a critical skill for both defenders protecting their own assets and OSINT investigators looking for an edge. Monitoring isn't just a passive activity. It gives us a real-time intelligence edge. From an OSINT and security perspective, we monitor websites for 4 key reasons. First, to detect uptime and blacklisting status. Is our target site down? Has it been flagged for malicious activity? Second, to catch fleeting changes. We can get alerts the moment a developer accidentally exposes a sensitive file or a new careers page goes live. Third, to discover new connections by monitoring for new backlinks. When another site links to our target, it tells us about a new relationship or partnership. And finally, to assess security risks by checking if a site is flagged for malware or phishing. Let's start with the most fundamental type, uptime and blacklist monitoring. This tells us if a website is online and if it's been flagged by major spam or security blacklists. A fantastic free tool for this dual purpose is Hetrix Tools. It allows you to monitor the uptime of your target websites and also checks them against dozens of blacklists, all for free. For an investigator, getting an alert that a target site has just been blacklisted is a major intelligence signal that something has gone wrong. All right, here we are on the Hetrix Tools website. And honestly, setting up a monitor here couldn't be easier. Step 1. Click Sign Up for a free account. Fill in your details, name, email, password, and hit Submit. You'll get a confirmation email, so just pop into your inbox, click Verify, and you're in. Once you're on the dashboard, you'll see two powerful free features: Uptime Monitoring and Blacklist Monitoring. Let's start with Uptime. Click Free Uptime Monitoring, then Manage Monitors. Here's where the magic happens. Just paste in the URL of the site you want to track, give it a name so you'll remember it, and pick up to 4 locations from where Hetrix Tools should monitor it. Click Add Monitor, and that's it. From now on, Hetrix Tools will check your site every single minute and alert you instantly if something goes wrong. This is the definition of set it and forget it. Now, for Blacklist Monitoring, it's just as easy. Go to Blacklist Monitors, click Add a Monitor, paste your site URL, give it a label, and add it. Hetrix Tools will automatically watch for any blacklist entries and alert you right away if your site's reputation is at risk. Simple, fast, and incredibly useful. Hetrix Tools is a must-have for anyone who wants to keep their website healthy and trouble-free. One of the most popular and reliable alternatives for uptime monitoring is Uptime Robot. As you can see on their website, Uptime Robot offers a generous number of free monitors along with plenty of integrations. The setup process is almost identical to Hetrix Tools. First, sign up by providing your email, full name, and password. Next, verify your email by clicking the link you receive in your inbox. Then sign in with your credentials. From there, add your target's URL and configure your alert settings. Uptime Robot will even send you a test email so you can see exactly how alerts will look. Their dashboard, right here, shows detailed statistics on uptime percentages and response times over days, weeks, and months. While it's often used by system administrators and defenders, an investigator can also leverage it to know the exact moment a target's critical infrastructure goes down. Another excellent and modern alternative is BetterStack, known for its clean, beautiful interface and powerful incident management features. Like the others, setting up an uptime monitor here is quick and easy. Where BetterStack really shines is in its detailed reporting and team collaboration tools. Even just using their free tier to track a few key targets can give you valuable uptime intelligence for an OSINT investigation. Getting started is simple. Enter your email address on the sign-up page, and you'll receive a sign-up link in your inbox. Click that link, and you'll begin the onboarding process. You'll be asked for your name, company size, and a few other details. When prompted, select that you're using it for uptime monitoring. Continue through the setup, then provide a phone number. This will receive a free test notification so you can see exactly how alerts will look. From there, choose the free plan. On your dashboard, click Create Monitor, enter the website URL you want to track, and you're done. Better Stack will start monitoring immediately and send you an alert if the site goes down. Now we move to one of the most powerful OSINT techniques, website change monitoring. This is how we catch new information the moment it appears. Our primary tool here is Visual Ping. It allows you to select a specific area of a web page and will send you an email alert with a screenshot the moment that area changes. Let's see how this works. I'm on visualping.io, and I'll paste in the URL for certifiedhacker.com. Visual Ping loads the page, and now I can literally draw a box around the exact section of the page I want to monitor. I'll set it to check for any changes and have it run daily. Then, I enter my email. And that's it. From this point on, if even a single word changes in that section, I'll get an email with a before and after screenshot. Think about the possibilities. Tracking a careers page for a new job posting that hints at a secret project, or watching a press's page for a sudden announcement. After you start, you'll receive a confirmation email. Just copy the code from that email and paste it here on the site. Next, choose the free plan, set a password, and click Continue. Finally, enter your name. Click Start Monitoring, and your account is ready. The dashboard will now display your current monitoring jobs so you can keep an eye on changes in real time. The ecosystem for change detection is vast, and I want to show you a few other great options. RoboTalp is a modern platform that offers a generous free plan for monitoring. Follow. That page is a classic no-frills tool. Its design is old, but it is incredibly simple and reliable for getting a basic email alert when text on a page changes. And Distill.io is a very powerful tool that comes as a browser extension. It allows for highly specific monitoring, such as tracking a number in a price tag or an item in a list, right from your browser. Our next form of monitoring is tracking backlinks. A backlink is created when another website links to your target. This is a huge OSINT signal, as it reveals relationships, partnerships, press mentions, and influence. A simple free tool to get a quick overview is Backlink Watch. Here on the site, you simply enter a domain, and it attempts to find and list the websites that are linking to it. This can be a great starting point for mapping a target's network of connections, though it's best for a quick, initial look rather than a deep, ongoing analysis. When you need to get serious about backlink analysis, the undisputed industry leader is Ahrefs. While their full suite is a premium paid product, their free backlink checker gives you a powerful glimpse into their data. Here, I'll enter CavemenTech.com and run the check. It will show us the domain's authority rating and a list of the top backlinks pointing to it. For deep corporate intelligence or competitive analysis, understanding a target's backlink profile is non-negotiable, and Ahrefs provides the most comprehensive data available. Finally, we monitor for security risks. Has a target website been compromised? Is it hosting malware or involved in a phishing campaign? Our number one tool for this is VirusTotal, a free service owned by Google that analyzes a URL against over 90 different security vendor databases. Using it is simple. You navigate to the URL tab, paste in the website you want to check, and hit enter. Here, we've scanned CavemenTech.com, and as you can see, it comes back with a score of 0 out of 97, meaning no security vendor has flagged it as malicious. This is your first stop for a quick security health check. For a much deeper technical dive, we use urlscan.io. When you submit a URL to urlscan.io, it doesn't just check it against a list. It actually visits the website in a sandboxed browser and records everything that happens. As you can see in this report, it shows you every IP address contacted, every domain requested, and every technology loaded. It's fantastic for understanding what a website is really doing in the background and for detecting malicious redirects or connections. Let's summarize your new monitoring toolkit into 4 key areas. For uptime and blacklist status, use Hetrix Tools or Uptime Robot. For tracking content changes, use Visual Ping or Distill.io. For discovering new connections, use Ahrefs to analyze backlinks. And for assessing security risks, use VirusTotal and urlscan.io. By setting up these monitors, you can turn a static investigation into a dynamic, real-time intelligence operation. Thank you for watching. In our next session, we'll continue to build on these concepts. I'll see you there. Hello everyone, and welcome back to our module on Web OSINT. Today, we're diving into a topic that sits at the crossroads of technical analysis and intelligence gathering: analyzing security headers. My name is Hassan, and by the end of this lecture, you'll know how to pull valuable information from a website without sending a single packet of malicious traffic. So, why should we, as OSINT investigators, care about something as technical as security headers? First, they are a website's first line of defense. They are instructions the web server gives to your browser on how to behave safely. This means they help protect against common attacks like cross-site scripting or XSS, clickjacking, and other nasty things. From an intelligence perspective, this is where it gets interesting. Missing or misconfigured headers are low-hanging fruit for attackers and bug bounty hunters. For us, they are a massive clue. They can tell us if a website is well-maintained, if it's a forgotten marketing site, or if the IT department is security conscious. It helps us build a profile of our target's security posture. There are many headers out there, but we're going to focus on a critical few. We'll be looking at content security policy, the bulldog of security headers, controlling what resources can be loaded. Strict transport security. This enforces secure encrypted connections. X-frame options. This prevents clickjacking attacks. X-content type options. Prevents the browser from making dangerous assumptions about file types. Referrer policy controls how much information is sent to other sites when you click a link. Permissions policy manages which browser features a site can use, like your camera or microphone. And finally, we'll touch on CORS-related headers, which can be a goldmine for finding serious security flaws. Let's break these down one by one. First up, Content Security Policy, or CSP. This is a big one. It gives the website fine-grained control over what resources the browser is allowed to load. This includes scripts, images, iframes, fonts, you name it. Its primary job is to prevent cross-site scripting and other data injection attacks. If an attacker manages to inject a malicious script onto a page, a strong CSP will block the browser from executing it. In the example here, default-src self means that by default, resources should only be loaded from the website's own origin. But then it makes an exception for scripts, allowing them from its own origin and from apis.google.com. A weak CSP, one that uses dangerous wildcards like a star or allows unsafe inline scripts, can often be bypassed, giving us a clue that while they've tried to implement security, they might not have done it perfectly. Next is HTTP Strict Transport Security, or HSTS. This header is simple but powerful. It forces the browser to use HTTPS connections. Once your browser sees this header from a website, it will remember for a set period, in this example, 1 year, to never connect to that site over unencrypted HTTP. It will automatically upgrade the connection to HTTPS. This prevents SSL stripping attacks, where an attacker tries to downgrade your connection to spy on your traffic. If this header is missing, it means a downgrade attack is possible, which is a significant risk for any site handling sensitive data. X-frame options is all about preventing an attack called clickjacking. This is where an attacker loads your website in a transparent iframe over their own malicious site and tricks you into clicking on things you can't see. There are two main values: deny, which blocks the page from being loaded in a frame anywhere, and same origin, which is more common and allows the page to be framed, but only by pages from the exact same domain. Seeing this header is a good sign of basic security hygiene. This header, X content type options, has only one value, no sniff, and its job is to prevent the browser from MIME sniffing. MIME sniffing is when a browser ignores what the server says a file is, and instead tries to guess the file type based on its content. This can be dangerous. For example, an attacker might upload a file that looks like an image, but is actually a malicious script. If the browser sniffs it and decides to run it as a script, you have an XSS vulnerability. The no sniff directive tells the browser to trust the server. If I say this is an image, treat it as an image, period. The referrer policy controls how much referrer information is sent when a user clicks a link to another site. The referrer tells the destination site where the user came from. This can sometimes leak sensitive information in the URL. A safer option, like no referrer when downgrade, ensures that this information is not sent when navigating from a secure HTTPS site to an insecure HTTP site. There are even stricter policies like no referrer, which sends no information at all. Permissions policy, formerly known as feature policy, is a modern header that lets a site control which powerful browser features it can use. This includes access to the camera, microphone, geolocation, and more. In this example, the empty parentheses with geolocation and microphone mean that access to geolocation and the microphone is disabled for all frames on this page. This is a great way to lock down your site and ensure that third-party content can't access sensitive user permissions. Finally, let's talk about CORS, or cross-origin resource sharing. These headers control who can access your APIs and resources from a different domain. Misconfiguring CORS is one of the most common and dangerous security mistakes. The two headers you see here are a toxic combination. Access control allow origin. Asterisk means a script on any website in the world is allowed to read the response from this server. Access control allow credentials. True means that the request can be made with the user's cookies and session information. When you see these two together on a site that requires login, it can often lead to a full account takeover or massive data exfiltration. It's a huge red flag. Okay, we've covered the theory. Now for the fun part, how do we actually find and analyze these headers? Let's look at some tools. The first and easiest tool is an online scanner called securityheaders.com, created by security researcher Scott Helm. All you have to do is enter the URL of the target website. Let's use the one from the slide, fordfleetcustomers.wexinc.com, and click Scan. And wow, we immediately get a result, an F grade. This is an OSINT jackpot. It tells us instantly that this site has a very poor security posture. As you can see, it lists the headers that are present in green, and more importantly, it shows all the missing headers in red with a red X. We can see it's missing strict transport security, content security policy, X-frame options, and more. This is actionable intelligence. It suggests this might be an older or less maintained part of their web presence. But what if you want to see the headers for a page that requires a login, or you want to see them in real time? For that, the best tool is already on your computer, your browser's own developer tools. You can open the developer tools by pressing F12 or right-clicking and choosing Inspect. Now, click on the Network tab. This tab records all the network requests the page makes. Let's refresh the page to capture the traffic. You'll see a list of requests. The very first one is usually the main page itself. Let's click on that. A new panel opens up. Here, you can see the response headers. And there they are, all the headers the server sent back. We can see the server header, the date, and any security headers that are present. This is the most direct way to see exactly what the server is telling your browser. Finally, for those who love the command line, there is the indispensable tool, curl. Curl is a powerful utility for making web requests. To see just the headers of a website, we can use the command curl, I followed by the URL. The -I flag tells curl to make a head request, which just asks the server for the headers without downloading the full page content. And there we have it. The raw header output, straight from the server. We see it's an Apache server. We see the last modified date, content type, and so on. That brings us to the end of our look at security headers. We've seen what they are, why they matter for security and OSINT, and how to use tools like securityheaders.com, your browser's developer tools, and curl to analyze them. Remember, these headers are a website's digital body language. Learning to read them will give you a much deeper understanding of your target. Thank you for watching, and I'll see you in the next lesson. Hello and welcome back to our Web OSINT module. Today, we're going to talk about finding what the server tries to hide from us, finding hidden directories and files. So, why is this so important? Because developers and system administrators often leave sensitive files and folders on a web server, thinking nobody will find them if they aren't linked anywhere. They might hide administrative panels, backup files, or staging versions of the website. These hidden endpoints can expose a treasure trove of information, configuration files that might contain database passwords or API keys, source code backups, which let us analyze the application offline for vulnerabilities, and of course, hidden admin panels that are the keys to the kingdom. From an OSINT perspective, finding a forgotten directory might reveal an old project, the names of developers, or the technologies being used. From a security perspective, these discoveries often lead directly to high-impact findings. There are several ways we can go about this, and we'll progress from the most passive to the most active. First, we have spidering. This is where we use an automated tool to follow every single link on a website to map it out. Next is mirroring, where we download an entire copy of a website to analyze it offline. Then we have pure OSINT techniques. This is where we use external resources like Google, GitHub, and the Wayback Machine to find directories that the website itself doesn't link to. Some of these techniques we have already seen. And finally, there's automated scanning or brute forcing, where we use tools and a word list to guess directory names. This is a more aggressive technique, and as the slide says, we'll be covering that in depth in the next section. Today, we'll focus on the first three. Let's start with web spidering. A spider, or a crawler, is a tool that starts at the homepage of a website and automatically follows every link it finds, mapping out the entire site structure. It's a great way to quickly discover all the pages, images, scripts, and directories that are meant to be public. Two of the most popular tools for this are the OWASP Zap Proxy, which you see here, and the Burp Suite Spider. Both have excellent free community additions. You simply give it a target URL, and it does the rest. But it's critical to understand the limitation. A spider can only find resources that are linked from somewhere else on the site. It will not find a truly orphaned file or a secret directory that has no inbound links. For that, we need other techniques. I'm on Kali Linux. First, let's update our repositories so we have the latest packages. Type sudo apt update. Now, to install the Zap proxy, use the command sudo apt install Zap proxy. And just like that, the tool is installed. To launch it, go to Applications, search for Zap, and click to open. From the main window, click on Automated Scan. Enter the website URL. For this demo, we'll use certifiedhacker.com, and then click Attack. The scan will start right away. At the bottom panel, you'll see all the URLs being discovered. On the left panel, Zap builds a site tree that shows the full structure of the target website. You can even right-click on any page in the tree and open it directly in your browser. So with just a few clicks, Zap allows us to automatically discover pages and directories on a website, a task that would take much longer if we tried to do it manually. Now, if you want to automate a lot of this passive OSINT work, a tool like Spiderfoot is fantastic. It's an OSINT automation framework. You give it a target, and it runs dozens of different modules to gather intelligence. It will check for subdomains, analyze headers, and yes, it will also scrape the website for linked files and endpoints. Using a tool like Spiderfoot is a great first step in any investigation because it does a lot of the passive reconnaissance for you before you move on to more hands-on techniques like mirroring or brute forcing. Spiderfoot is already installed on Kali Linux. To launch it, we use the command spiderfoot-l. Here, the -l option lets us specify the listening IP and port. In our case, we'll keep it simple and use localhost. Once it starts, Spiderfoot will launch in the background and display a server URL. Copy that URL, open it in your browser, and you'll see the Spiderfoot interface up and running. Spiderfoot is quite a powerful tool, and you can extend its functionality by adding API keys for different services. To do this, just go into Settings, add your API keys, and Spiderfoot will integrate with those services. For this demo, though, we'll stick with the default setup. To launch a new scan, click on New Scan. Give your scan a name and enter your target URL. Here, we'll use certifiedhacker.com. Spiderfoot allows you to run different types of scans, but for now, we'll select the Complete Scan option and click Run Scan Now. The scan will begin, and keep in mind that Spiderfoot can take more than 30 minutes to finish, depending on the scope. Once the scan is complete, you'll be presented with a dashboard that summarizes the results. Spiderfoot extracts all kinds of information, such as email addresses, DNS details, subdomains and directories, and even page content. You can scroll through the results and examine the HTML content of discovered pages as well. This makes Spiderfoot extremely useful for content discovery and for building a complete OSINT profile of a website. Our next technique is mirroring. The idea is to download an entire copy of the target website to our local machine. Why would we do this? It allows us to browse and analyze the site's structure, code, and files offline, without sending constant requests to the target server, which is much stealthier. While there are many tools that can do this, as you can see on this slide, we're going to focus on the two most common and powerful ones: a command line classic, wget, and a user-friendly GUI tool, httrack. Let's start with wget. This is a standard tool that comes pre-installed on most Linux systems, including Kali Linux. To download an entire website, we simply use the wget command with the website's URL. wget will automatically start downloading the site and saving its files locally. Once the download is complete, navigate to the respective folder, and you'll find an index.html file. Open this file in your browser, and you can now browse the website offline, just like you would online. In addition, you can go through the individual files in the downloaded folder, such as images, scripts, and style sheets, and analyze them in detail. This makes wget a simple but powerful tool for capturing and studying the structure and content of a website. If you're not a fan of the command line, httrack is a great alternative. It's a free, open-source tool with a graphical interface that makes downloading a website much easier. No need to type complex commands. To get it, go to the official httrack website and open the download page. Download the 64-bit version, and once the download is complete, install it. Just follow the on-screen instructions to finish the installation. Now, open httrack. Click on New Project, give your project a name, and enter the target website URL. Before starting, click on Set Options. Make sure to remove any proxy settings, and under Scan Rules, select all file types so nothing gets skipped. Now, click Go to start scraping the website. httrack will begin mirroring the entire site. Once the process is finished, click on Browse Mirrored Website. You can now open and explore the website locally, just like it's online. And just like with wget, you can also go through the downloaded files, HTML, images, scripts, and analyze them in detail. So to recap, we've explored several semi-passive ways to discover a website's structure. We can spider it to map its public links, mirror it to perform a deep dive analysis offline, and use OSINT tools like Spiderfoot to automate the initial recon. These techniques are essential for building a complete picture of your target. Thank you for your attention, and I'll see you next time. Hello and welcome! In our previous lectures, we learned how to find specific pieces of information using specialized tools. But what if you need a complete picture of a website fast? That's where website information aggregators come in. These are powerful all-in-one tools that gather, correlate, and present a huge amount of data in a single report. So, why use an aggregator instead of individual tools? It comes down to three things: speed and efficiency. You can get a comprehensive report in seconds, not hours. Data correlation. These tools are designed to show you how different data points, like whois, DNS, and hosting information, all connect together. And discovering hidden connections. Aggregators often have their own historical databases that can reveal relationships you might otherwise miss. They save you an incredible amount of time. Our first aggregator is a modern dashboard-style tool called WebCheck. It provides a fantastic visual summary of a website's technical and security profile. Let us see a brief demo. Navigate to webcheck.as93.net. Enter your target URL certifiedhacker.com. Let the report load. Look at this dashboard. In just a few seconds, we have everything in one place. Here's the SSL certificate details. We have the DNS records, including the IP address. It even runs a security headers check and checks the site against block lists. If you scroll down, you can also view a list of tools that you can explore to further analyze the website. This is a perfect example of an aggregator giving you a complete, high-level overview in one go. Next, we have an industry veteran, Netcraft. Netcraft has been collecting data about the internet for decades, making their site report an authoritative source for infrastructure analysis. Navigate to sitereport.netcraft.com, enter the target URL. Netcraft's report excels at showing the history and infrastructure of a site. Here under the Network section, we can see the NetBlock owner, the hosting company, and the name server organization. Similarly, we have information about geolocation, SSL and TLS certificates, etc. Our final tool is another classic OSINT favorite, the domain dossier from Central Ops. This tool is loved by investigators for its fast, comprehensive text-based reports. Navigate to centralops.net. Enter the target URL and check the boxes for the information you want. For example, domain whois, DNS tracer root. Run the query. The power of the domain dossier is that it combines all of these checks into a single report that is very easy to read, copy, and paste into your own investigation notes. We get the IP address, the domain, who is record, the DNS records, and even a network tracer route, all in one consolidated view. It's an incredibly efficient tool for initial reconnaissance. So, let's summarize when to use each aggregator. For a quick, modern, and highly visual overview that includes security checks, use WebCheck. For a deep dive into a website's infrastructure and hosting history, use the authoritative data from Netcraft. And for a fast, comprehensive, text-based report that combines multiple checks into one, use Central Ops. By having these powerful aggregators in your toolkit, you can drastically speed up the initial phase of any website investigation. Thank you for watching, and take care. Hello everyone, and welcome to the next lecture in our reconnaissance module. Today, we're moving beyond basic subdomain enumeration into something much more powerful. The title of this lecture is Advanced Recon, a SN and IP address enumeration. So, what's our goal today? Our primary aim is to identify the apex domains and the full IP address ranges that our target organization owns. We'll do this by learning about something called ASN numbers and using a variety of advanced techniques and tools. This method allows us to build a complete map of our target's internet footprint, often revealing assets they've forgotten about. The entire process starts with finding the target's autonomous system number, or ASN. Think of an ASN as a unique ID for a large network on the internet. ASNs are assigned to entities like internet service providers, cloud providers, and large corporations. By finding a company's ASN, we can find the IP addresses of servers they own, which will in turn lead us to more websites and domains. One of the most reliable ways to find these numbers is by manually searching on Hurricane Electric's BGP Toolkit website, which you can find at bgp.he.net. Now, it's important to remember that with the rise of cloud infrastructure, a company's assets might be on AWS or Google Cloud, not just in their own ASN. So, this isn't a complete picture, but it's an incredibly powerful starting point for finding their core on-premise infrastructure. Alright, that's the theory. Let's see this in action. Okay, I'm here at Hurricane Electric website. In the search bar, I'm going to type our example target, Twitch, and hit search. Instantly, we get a list of results. You can see right at the top, under the result column, two ASNs, AS46489 and AS397153, both described as belonging to Twitch Interactive Incorporate. Below that, we see a list of IP ranges, which are listed here as routes. This is exactly what we were looking for. Let's dig deeper. I'm going to click on the first ASN, AS46489, to see all the network prefixes associated with it. After clicking that link, Hurricane Electric shows us a detailed page for that ASN. This Prefixes v4 tab is a goldmine. It lists all of the IPv4 address blocks, or CIDR ranges, that are registered under this specific ASN. We can see all ranges belonging to Twitch. This is great, but copying and pasting from a website isn't very efficient. Let's use a command line tool to automate this. For this step, we'll use a tool from Project Discovery called ASN Map. It's lightweight and fast. You give it an ASN, and it returns every IP range associated with it. Let's jump into the terminal and run it. Installing the tool is straightforward. Head to the project's GitHub page, where you'll find the complete installation instructions. First, install Go on your machine. Run sudo apt install golang-go. Go should install in a few seconds. Next, install ASN map using Go's install command as shown in the repo. The binary will be placed in your Go bin directory. To confirm everything worked, change to that directory and type /asnmap-help. The syntax is very simple. I'll run ASN map in silent machine readable mode against ASN AS46489. Just type ASN map-silent -A and the ASN number AS46489 and hit enter. And there you go. In seconds, ASN map returns a clean list of CIDR ranges for Twitch. This list is our map for the next stages of reconnaissance. We now have a defined network scope to investigate. Before we start scanning, it's good to know about the regional internet registries, or RIRS organizations like ARIN in North America and RIPE in Europe are responsible for allocating these IP address blocks and ASNs. Their databases are the source of truth for who owns what on the internet. We can use their whois search functions to get detailed information on any IP range we find. Let's quickly look up one of the ranges we just found using ARIN. I'm on the ARIN whois search page now. I'll take one of the larger ranges we found, 52.2, 23.1, 9, 2.0, and paste it into the search. The result gives us the official record. We can see the net range, the CIDR notation, and confirm the organization it's registered to. Twitch Interactive Incorporated. This is a great way to verify ownership of the assets you discover. Another fantastic resource is the website ipinfo.io. It aggregates a ton of data and presents it in a very clean interface. You can use it to look up information on an IP address, or in our case, an entire ASN. One of its most powerful features for us is the hosted domains lookup, which can perform a reverse IP search to find domains associated with an IP range. Let's see what it has on our Twitch ASN. I'm going to search for AS46489 on ipinfo.io. The page gives us a great summary, the date the IP range was allocated, and all the associated IP ranges. We have the complete whois record, including the email contact information. If you scroll down, we can see the hosted domains. This feature scans the ASN's IP space and looks for hosted websites. And look at this. It has identified xarth.com and justin.tv as domains hosted within this network. We've just found another potential target domain. Now, let's shift our focus on internet search engines. Let's talk about one of the most powerful tools in any hacker's arsenal, Shodan. Shodan is often called the search engine for hackers. It continuously scans the entire internet on thousands of ports and saves the results. It doesn't just see what ports are open, it grabs all the response data, like banners, service versions, and SSL certificates, and makes it all searchable. This cheat sheet shows some of the powerful search filters you can use. For our purposes today, the most important ones are ASN:, which lets us search by the ASN we found, and net:, which lets us search within a specific IP range. Enough talk. Let's use Shodan to explore Twitch's infrastructure. Here on Shodan.io, I'm going to use the ASN filter. In the search bar, I'll type ASN:AS46489. And wow, we have over 1,500 results. These are all the devices, servers, and services that Shodan has found inside Twitch's network space. We can see a map of where they are located and a breakdown of the most common open ports. Shodan provides all the raw banner data, but the most interesting part for us is often the SSL certificate information. If we look under Issued To on the certificates, we can find new subdomains. From here, export or collect the certificate host names and validate them with DNS lookups. These subdomains become targets for the next phase. The OWASP Amass project is another essential tool for asset discovery. Its Intel module is perfect for our workflow. We can give it an ASN, and it will use various data sources to discover root domains associated with that organization. Let's use it to quickly find all of Twitch's core web properties. Back in my terminal, I'm going to run the command amass intel, ASN 46489. Amass is now doing its thing, querying data sources and piecing together the information. And there's our result. It has identified Justin.tv. This is an incredibly fast and effective way to find the main seed domains to start a deeper investigation. Now let's talk about automation. The tool Karma is a passive OSINT framework that automates a lot of our Shodan queries. It utilizes the Shodan API to automatically gather information about a target, including vulnerable IP addresses and infrastructure details. Let me show you a quick example of how it can speed up your workflow. I am on the Karma GitHub page. Here we have the complete installation instructions. First, clone the repository. Next, change into the project folder. Now we need to install a few dependencies. Install Shodan and MMH 3 Python modules. If you get an error, append the break system packages flag to the installation command. Next, install the JQ parser with apt install JQ. Now install the HTTP probe. Next, install interlace. Next is the installation of Nuclei. Use the go install command to install it. In parallel, we can also install lolcat. And lastly, we need to install a new. Now we need our API token from Shodan. Go to Shodan, open account settings, and copy the API token. Enter it in the token file expected by Karma. After configuring Karma with my Shodan API key, I can run it against one of the domains we found, like twitch.tv. Let's first check the help menu. The command would be bash karma-dh. And here we can see that we only need to provide the domain and the mode as required parameters. Let's run the ASN scan against Twitch.tv. Karma will then run a series of predefined intelligent Shodan queries in the background and present me with a consolidated report of its findings. Karma saves results in the output directory. Let's explore it. You'll find a summary file, twitch.data. If we cat the twitch.data file, we can see IP addresses, subdomains, and ASN numbers. This is a great way to automate the initial information gathering phase. Next up is SMAP. SMAP is a clever tool that acts as a port scanner but is completely passive. It's built on Shodan's free API. The best part is that it uses the exact same command line arguments as Nmap and produces nearly identical output. This means you can use it as a drop-in replacement for Nmap when you want to do a quick, stealthy scan without sending a single packet to the target. Let's try it out. The installation is very simple. Just use the go install command from the GitHub repo. The tool will be installed in the default Go directory. Move into the Go bin directory. Here we have our tool. We can check the syntax with the command smap-h. Now I'm going to scan a Twitch subdomain. Instead of typing nmap, I'll type smap-svassets.twitch.tv. As you can see, the output looks just like nmap. It shows open ports and the services running on them. But remember, this scan was completely passive. SMAP simply queried Shodan's database for its latest information on this host and formatted it for us. It's an amazing tool for getting a quick overview without revealing your activity. We can also run a scan against certifiedhacker.com. That scan is quite comprehensive, and again, it is completely passive. Finally, let's talk about active scanning with Nabu. Nabu is another tool from Project Discovery. It's a very fast and reliable port scanner written in Go. It's designed to do one thing and do it well. Quickly perform SYN, connect, or UDP scans on a list of hosts to find open ports. The installation is very simple. Use the command sudo apt install Nabu, and Nabu will be installed. We can check the syntax with nabu-h. We only need to provide the host for the scan to run. Let us run the scan with the command nabu-host certifiedhacker.com. Here we can see all open ports for our target. Its true power is realized when we chain it with our other tools. We can use ASN map to get the list of IP addresses for our target, just like we did before, and then we can pipe that entire list of IP ranges directly into Nabu for an active scan. Nabu will actively scan every single IP address in all of those ranges for open ports. Alright, the last tool we'll briefly touch on is Census. Just like Shodan, Census is another powerful platform for internet-wide scanning. It continuously scans devices across the internet, collecting data to help security teams and researchers get a comprehensive view of their attack surface. While we won't be doing a demo of it today, it's important to know it exists as a powerful alternative or supplement to Shodan for your reconnaissance. It's another excellent tool to have in your arsenal. So, let's quickly summarize what we learned today. First, start with the ASN. Discovering a target's autonomous system number is the key to unlocking and mapping their entire network infrastructure. Second, follow the Recon workflow. Use that ASN to find all associated IP ranges, and then scan those ranges to discover live hosts and new, hidden domains. Remember to combine passive and active scanning. Use tools like Shodan for stealthy, initial discovery, and then follow up with active scanners like Nabu for a more comprehensive and real-time view. And finally, the most efficient way to work is to chain your tools to automate your process. Piping the output of one tool directly into another builds a powerful and fast scanning workflow. Thank you for watching, and I'll see you in the next lecture. Welcome back. Today, we are re-diving into the world of vulnerability scanners. If you're currently doing manual recon across hundreds of endpoints, you already know it is slow and error-prone. That's where automation comes in to save the day. Scanners can test thousands of known issues in minutes, identifying known CVEs, security misconfigurations, exposed panels, and default credentials. They provide consistent, repeatable coverage that never forgets a check, which ultimately frees up your time to hunt for those creative, manual bugs that automated scanners miss. The real magic happens when you chain these tools together. You can point a scanner at a single target or an entire list, and it automatically crawls, fingerprints, and fires payloads for you. For example, you can chain tools into a pipeline to find subdomains, filter for live hosts, scan them, and save a report, all using just one command. Schedule this in cron or CI, and you've got continuous, hands-off monitoring for your entire scope. Let's start with a classic, Nikto. Nikto is an open-source web server scanner that performs comprehensive tests against web servers. It checks for over 6,700 potentially dangerous files and programs, and looks for outdated versions on over 250 servers. It even checks for server configuration issues, like multiple index files or HTTP server options, giving you a great baseline of your target's posture. Let's look at Nikto in action. We simply pass our target URL to the tool. Notice how quickly it grabs the server version. In this case, Nginx 1.19.0, and starts flagging missing security headers like X-frame options and X-content type options. It's straightforward, fast, and gives you actionable configuration data right out of the box. However, it is only a basic scanner and focuses on very limited vulnerabilities. Next up is a modern favorite, Nuclei. Nuclei is a fast, template-based vulnerability scanner created by Project Discovery. Instead of relying on hard-coded checks, it reads simple YAML templates, each describing exactly how to detect one specific issue. The community is incredibly active, shipping over 9,000 templates that cover CVEs, misconfigurations, and subdomain takeovers. In fact, new CVEs often get a template within hours of disclosure, ensuring your scans stay current. Because a template defines the exact request to send, and the matchers that confirm a finding, Nuclei keeps false positives very low. It is a single Go binary that drops straight into CI/CD and Bug Bounty Recon pipelines. Nuclei is a powerful open-source tool hosted on GitHub, where you can find its full description and the protocols it supports. However, instead of installing it directly from GitHub, I'm going to use the package manager included in Kali Linux. Simply run the command sudo apt install nuclei. This will automatically fetch and install the package for us. Once installed, we can check the syntax and pull up the help menu using the command nuclei-h. And right here, we have the complete syntax overview. Now, let's run it against a vulnerable target. We are going to do a simple scan, so we only need to provide our target using the -target flag. If this is your first time running Nuclei, it will automatically download the latest templates first. Then, it will immediately begin testing the site against those templates one by one. As you can see here, it first detects the architecture and technologies running on the site. From there, it fires off its templates, quickly listing vulnerabilities such as missing security headers. If you take the time to fine-tune this tool with specific templates, you can essentially uncover a massive range of vulnerabilities across a system. It truly is a go-to tool for modern bug bounty hunters. Moving on to Wapiti. Unlike tools that look at source code, Wapiti works as a black box's vulnerability scanner. It audits the security of your web applications by crawling the deployed web pages, looking for scripts and forms where it can inject data. Once it maps out the URLs and inputs, Wapiti acts like a fuzzer, sending payloads and looking for error messages, special strings, or abnormal behaviors to see if a script is vulnerable. Let's see how Wapiti handles authenticated scans. First, we use the wapiti-get cookie command to pass our login credentials and save the session cookie to a JSON file. Once authenticated, we launch our main scan. It's a highly customizable fuzzing engine. Wapiti is another fantastic open-source scanner, and you can find its full documentation right on their official website. For this demo, we're going to install it using Python's package manager, pip. Let's start by creating a new directory in Kali Linux and moving into it. Next, we'll create a Python virtual environment. This is a crucial step to ensure that installing packages via pip doesn't conflict with or break any of our native Kali system packages. Once the virtual environment is activated, simply run the command pip install wapiti3. This will automatically fetch and install Wapiti along with any required dependencies. And just like that, our tool is ready to go. For our target, we are going to scan this simple one-page site. It is intentionally vulnerable and packed with security flaws for us to find. Let's fire it up. Use the command wapiti-u followed by our target URL. Hit enter and Wapiti immediately begins scanning the application. On the screen, you can see it actively fuzzing the site with various malicious payloads and analyzing the server's responses. As it discovers vulnerabilities, it logs them right here in the terminal in real time. Once the scan completes, Wapiti generates a highly detailed, comprehensive report. If we open this HTML report in Firefox, we are greeted with a clean summary of every vulnerability it uncovered. Clicking on any specific finding reveals the complete details, including the exact location or parameter where the flaw exists. It even provides the raw HTTP request and a ready-to-use curl command, making it incredibly easy for you to manually verify and test the vulnerability yourself. Finally, we have a Titan in web scanning, OWASP Zap, or the Z-Attack proxy, now maintained by the Checkmarks team. Zap sits directly between your browser and the target as a proxy, analyzing and attacking the traffic it sees. It features a passive scan that inspects requests safely, and an active scan that injects payloads to test for heavy hitters like XSS and SQL injection. While Zap has a fantastic desktop GUI, it can also run fully headless in Docker, dropping straight into your automation pipeline. A Wasp Zap is conveniently available right in the Kali Linux repositories. To get started, let's first update our package lists using the sudo apt update command. And then we can install the tool using sudo apt install ZA proxy. Once the installation is complete, we can launch the GUI by typing owaspzap in our terminal. When the application opens, you will be asked how you want to handle the session. For this quick scan, just select the option not to persist the session. Right on the Quick Start homepage, we have an excellent option for an automated scan. It may prompt you to download some add-on updates, but for the sake of this demo, I am going to skip them. Simply paste your target URL into the box and click the Attack button. Zap immediately gets to work. It will automatically spider and crawl the web pages, actively looking for vulnerabilities and misconfigurations across the site. As it tests, we are presented with all the discovered vulnerabilities, neatly categorized in the alerts box in the bottom left corner. Zap is an incredibly robust scanner and a fantastic tool to help you quickly find that low-hanging fruit during your bug bounty recon. And there you have it, a powerful toolkit to automate your reconnaissance and free up your time for manual hunting. Thanks for watching, and if you found this helpful, don't forget to like and subscribe. So far, we have focused on profiling a target under a single domain name. However, modern enterprises run multiple brands, and parent companies frequently absorb smaller organizations. Every acquisition represents a completely new Apex domain and a fresh, often forgotten attack surface. In this section, we will take a major parent company, Tesla, and use corporate OSINT to uncover its subsidiaries, legal entities, and hidden domains using entirely public infrastructure. Our first stop is Crunchbase, a highly effective business analytics aggregator that tracks corporate funding, sub-organizations, and acquisitions. Switch to the browser and navigate to crunchbase.com. If you haven't already, you can quickly set up a free account here. Next, search for Tesla in the main search bar. As we scroll down the organization profile, Crunchbase populates detailed financial information about Tesla, including its funding history, key leadership, and IPO details. Continuing down, let's look at the acquisitions section. We can see that Crunchbase tracks a timeline of acquisitions by Tesla, such as SolarCity back in 2016. Each of these unique business names serves as a powerful seed for domain pivoting. For instance, SolarCity points us directly to solarcity.com, while Maxwell Technologies gives us maxwell.com. You can click on any acquisition name to instantly pivot your information gathering to that specific target. However, keep in mind that the free tier of Crunchbase limits how much data you can view. To seamlessly fill in these gaps, we can turn to Wikipedia next. While it may seem basic, it is easily the fastest human-readable map of a target's corporate layout. The primary advantage here is that the Wiki info box maps out key subsidiaries, and every major merger or acquisition entry links directly to a footnoted primary source, such as an SEC filing, which we can pivot to later. Open the Tesla article in your browser. Scroll down and we get a clean historical timeline of the company. we can review the founding history, the entities that gave birth to Tesla, and all of its subsidiaries and acquisitions. We can also see a clear list of former and current partners. Every single one of these names represents a brand new Apex domain that we can enumerate. Moving past aggregators, we turn to the single most authoritative primary source for U.S. public companies, the SEC Edgar database. Every publicly traded company is legally required to attach Exhibit 21.1, known as the subsidiaries of the registrant, to its annual 10-K filing. This provides an official, comprehensive list of corporate entities and their exact legal jurisdictions. Let's navigate to sec.gov/Edgar/search and search for Tesla. We can filter our search specifically for Exhibit 21.1. We get a complete history of the exhibits that Tesla has attached to its annual filings over the years. Let's open the most recent filing. By extracting Tesla's official Exhibit 21.1, we see a massive list running over 500 distinct legal entities. Right here, we find Tesla Energy Operations, Tesla Motors Netherlands, Perbix Machine Company, and multiple Solar City LLCs. Here is a professional Recon tip. Download the Exhibit 21 from the previous fiscal year and diff the two files. Detecting a newly added entity is often exactly how you can pinpoint a secret acquisition before it is ever formally announced to the public. While the SEC covers U.S. filings, Open Corporates allows us to map the rest of the world. It is the largest open database of corporate entities globally, constructed purely from official government registries. It aggregates international corporate groupings, helping us identify exactly how foreign branches and regional entities tie back to the primary parent organization. Let's open opencorporates.com and run a search for Tesla Motors. This search instantly brings up the global corporate tree. Right away, we find entities like Tesla Motors Netherlands, Tesla Motors Canada ULC, and various state-level leasing branches. We can also filter these results by region to pinpoint companies in an exact geographic area. A quick word of caution here: simple name searches will often yield unrelated namesakes, so always verify that the registry record actually matches your target before moving it into your scope file. To ensure completely thorough coverage, you can layer a few additional corporate OSINT platforms into your Recon workflow. Dun & Bradstreet allows you to analyze corporate family trees via DUNS numbers, often catching smaller operational branches that SEC filings leave out. For complex or offshore jurisdictions like China and Russia, Sayari is an excellent commercial choice. Finally, you can map executive relationships using LittleSys and pivot to bgp.he.net to discover target-owned ASNs and net blocks, converting infrastructure directly into IP scopes. Why does corporate reconnaissance matter so much? Because when a parent company acquires another business, they inherit its entire security posture, whether it has been properly audited or not. Take the massive Marriott and Starwood breach. Marriott finalized the acquisition of Starwood in 2016, but attackers had already compromised Starwood's internal networks back in 2014. The breach went completely unnoticed until 2018, exposing 339 million customer records and over 5 million unencrypted passport numbers from a legacy, unmonitored system. This is highly relevant to bug bounty operations right now. In recent history, security researchers targeted a freshly acquired subsidiary that had just entered a program's scope. By auditing its legacy systems and analyzing exposed code, They uncovered a private source code repository and an active NPM token inside a public Docker Hub image, leading to a critical supply chain, remote code execution, and a $50,500 payout. Newly acquired infrastructure is consistently a softer target than the hardened primary parent company. To summarize the workflow, extract the acquisitions, map out the global legal entities, convert those business names into valid Apex domains, and heavily prioritize the older, legacy systems. That is exactly where the unmonitored vulnerabilities reside. Thank you for watching, and I will see you in the next lecture. Welcome back to CavemenTech. Today, we are diving into a critical aspect of web infrastructure security, discovering the origin server behind a content delivery network like Cloudflare. Why does this matter? If a security researcher or bug hunter can unmask the real IP address, it reveals the target's true security posture and provides valuable infrastructure clues. Finding the origin IP often exposes missing or misconfigured headers, which are considered low-hanging fruit and can lead to quick wins in bug bounty reports. Cloudflare acts as the first line of defense against attacks such as cross-site scripting, clickjacking, and MIME sniffing. So, in this video, we are going to learn how to bypass Cloudflare and find actual IP addresses. Before we jump into the tools, let's talk about why this matters. First, let's look at the goal. Unmasking the real IP address reveals the target's true security posture and gives us vital infrastructure clues that the CDN normally hides. From a defense perspective, a CDN like Cloudflare acts as the primary shield, the first line of defense against common web vulnerabilities, including cross-site scripting, clickjacking, and MIME sniffing. This is exactly why discovering the origin is a goldmine for bug hunters. Origin servers often lack the strict security configurations of the edge network, meaning missing or misconfigured headers on the origin server become easily accessible low-hanging fruit. Ultimately, the impact of finding that origin IP is huge. It can lead to quick wins in your bug bounty reports by exposing vulnerabilities that were supposed to be protected by the proxy. Step 1 is simple but crucial: verification. Before we start hunting for hidden servers, we need to answer one basic question. Is the target actually using Cloudflare in the first place? If they aren't, we are overcomplicating things. We can use a quick online verification tool to confirm if the domain is routing through Cloudflare's proxy network, or if the real IP is already sitting right out in the open. Here is how that looks in practice. First up, let's look at a quick web tool to verify our target. Check for Cloudflare. Let's test a domain first, rapfame.app. As it runs the scan, the results come back instantly. It clearly tells us this website is not using Cloudflare. That means its real IP address is already sitting right out in the open, and we don't need any advanced tricks to find it. But watch what happens if we plug in a different domain, like buyyoutubeviews.com. The tool updates and shows us straight away that this website is using Cloudflare. Similarly, let's test one more, private internet access. As you can see, this one also comes back verified as sitting safely behind Cloudflare's proxy protection. Now that we've confirmed our targets are protected, we know we actually need to look deeper. If the target is using a CDN, one theoretical approach to finding the origin is examining historical data. Administrators sometimes set up a server on a public IP before putting it behind a proxy. Web-based databases and online resolvers can be used to see if the origin IP has been leaked or historically recorded before the proxy was implemented. One great web-based tool for this is the Skype IP Resolver. Let's enter our target website, Buy YouTube Views. What this database does is scan through known subdomains to see if any historical or adjacent records are bypassing Cloudflare's DNS. As you can see right here, it managed to uncover an active IP address. Similarly, let's check our other target, Private Internet Access. When we run this one, the tool successfully pulls up multiple IP addresses associated with the infrastructure. Now, to analyze these discovered IP addresses, we need to gather a bit more context. Let's head over to iplocation.io. We just paste the IP address we found into the search bar and click Analyze. Instantly, we get a breakdown of the IP's geolocation, the hosting provider, and the organization it belongs to, giving us a much clearer picture of the actual backend environment. When historical records are clean, the primary mechanism used to identify origin infrastructure shifts to subdomain misalignment. Automated auditing tools look for gaps in an organization's split horizon DNS or wildcard configurations. Moving on to automated tools, the first one we will look at is CloudRip. This tool is designed to automate the process of finding real IP addresses hidden behind Cloudflare by brute forcing and checking subdomains. CloudRip is available on GitHub, and setting it up is straightforward. First, we will git clone the repository and move into the downloaded directory. To keep our system clean and avoid breaking any globally installed packages, let's spin up a Python virtual environment using the command python3-mvenv. Once that is created, we activate it using the source command. Next, we run the final installation command, pip install -r requirements.txt. This automatically pulls in all the prerequisites the tool needs to run. Now we are ready to hunt. We just execute the tool using python3cloudrip.py, followed by our target domain, privateinternetaccess.com. As it runs, it checks the root domain, and then immediately starts scanning the subdomains for any IP leaks. And right here at the bottom, we can see a hit. It successfully found a subdomain that resolves to a direct public IP address, bypassing the CDN entirely. The next tool in our arsenal is CloakQuester. This tool focuses heavily on subdomain enumeration and passive analysis techniques to identify potential origin IP exposure for websites protected by Cloudflare and other reverse proxies. To get started, we first git clone the repository. Move into the newly created directory, and then install the dependencies using the pip install -r requirements.txt command. A quick tip here: if your terminal throws an externally managed environment error, simply add the -- break system packages flag at the end of your pip command to force the installation. Once that finishes, our tool is ready to go. To run it, simply execute python3 CloakQuester, followed by our target domain. It will verify the Cloudflare protection, grab its word list, and start scanning for subdomains. And there we have it. The scan finishes and successfully reveals a few subdomains along with their real, underlying IP addresses. The next tool we have is Zono CF Leak, developed by Zono Security. This tool is designed to identify real origin IP addresses hidden behind Cloudflare protection by analyzing subdomains and various infrastructure misconfigurations. The installation process follows a similar flow to what we've done before. First, git clone the repository and move into the project folder. Next, create a clean Python virtual environment using Python 3. Once created, activate it and run your pip command to install the necessary requirements. The usage here is incredibly simple. Just run the command python3 xenocfleak.py followed by the target domain name. The tool immediately loads its domain list and starts scanning through the subdomains, looking for any IP leakages. It filters out the proxy traffic, and as you can see right here in the terminal output, it has successfully uncovered multiple non-Cloudflare IP addresses, pointing straight to the backend infrastructure. The final automated tool we will cover is Origin IP Bypass, developed by Malik Hamza. This is a powerful Python-based tool designed to discover the true origin IP of a target by actively bypassing web application firewall protection. It handles subdomain enumeration, detects unprotected endpoints, extracts ASIN details, and scans for exposed web services to map out the infrastructure. The installation process follows the exact same workflow we've been using. First, git clone the repository, navigate into the project folder, and run your pip command to install the necessary requirements. The usage here is incredibly straightforward. Just execute the tool using the command python main.py-d followed by your target domain. The tool immediately kicks off its workflow by initiating subdomain enumeration. It automatically analyzes each endpoint, filtering out the WAF protections, and clearly lists which subdomains are actively routed through Cloudflare and which ones are left completely unprotected. Finally, it compiles everything into a clean list of exposed backend IP addresses, giving you a definitive look at the target's true perimeter. That's all for this video. Thanks for watching. Understanding these mechanics is crucial for securing infrastructure, as a CDN is only as strong as its origin's perimeter. See you in the next video.